All right, come on, guys. Guys. Go ahead and put these in your calculator in L1 and L2 and find the mean and standard deviation for it. So we're putting these in the calculator, finding our mean and standard deviation. Then. Stop. Come on. Did y'all finish? What's your mean? Standard deviation. And they do 943, so I'm gonna leave it at that. I would do 3 decimals in stats in calc. I think you're supposed to do 4. I would not trust 2. I didn't. I didn't. All right. Suppose the dealership's manager receives $500 bonus from the company for each car sold, 500 for each car. Let Y equal the bonus received from car sales during the first hour on a randomly selected Friday. Find the mean and the standard deviation of Y. So what are we doing? First of all, we're looking for Y. What are we doing to it? Are you? Because he receives 500 for each car. 500 per car, right? Okay. So then how would I find the mean? We are multiplying. So is mean affected by multiplication? Yeah, it's affected by everything, right? Right? So we're going to do all the calculations, 500. What was our mean for X? Sorry, this should be mean Y. What was our mean for X? 1.1, which gives us 550. To find our standard deviation of Y, is standard deviation affected by multiplication? Yes or no? Be confident when you say this, because I need you to be more confident since that's all we've done all period. So we're doing 500 times the standard deviation because it is affected by multiplication. And we get 471.50. That's part 1. That's all. All right. So to encourage customers to buy cars on Friday mornings, the manager spends $75. The manager spends $75 to provide coffee and donuts. The manager's net profit T on a randomly selected Friday. So T is the bonus earned. So what do we label the bonus? What letter? No, we already did it. Why? Minus this 75. You have to be able to set up your equation, okay? Make sure you have that, and it's got to have the right variable. How do we know it's Y? Set it up here. Y is the bonus received from car sales. Yeah, it's okay. It's okay. Just look for that from now on. All right. So we want to find the mean and standard deviation of T. So the mean of T is mean affected by subtraction. Yes, it's affected by everything, right? So we'll take our mean that we just found, our mean of Y, and subtract 75. So our mean of Y was 550. We're going to subtract 75, and we get 475. Everybody good? All right. Standard deviation of T is standard deviation affected by add or subtract. It will not change, so it's just equal to the Y, which was 471.50. It is not affected. If you need to put that on your notes, please write that on your notes. That's it. That's your check your understanding. Your homework is going to look like that. All right, 2 more pages. I promise we're done. All right, putting it all together, just reviewing it again, adding, subtracting, multiplying, dividing. So what happens if we transform a random variable by both adding or subtracting a constant and multiplying or dividing by a constant? Let's consider Peach Jeep tours again. We could have gone directly from the number of passengers X on a randomly selected Jeep tour to Pete's profit V with the equation. So what did we do to the number of passengers in every example? What were we doing altogether? Remember, I told you that. What did we do the first time? What did we do the first time to the number of passengers? Multiply by 150. What did we do the second time? So they're saying we can just do this all at the same time. We don't have to do it separate. So what would that equation be for that V? That perfect. Or because remember, I told you when we do our linear stuff, so we found our line of best fit or whatever earlier, they do it backwards and they do A plus BX instead of AX plus B. Y'all know what I'm talking about? So that's what we're going to do here is just switch it around. So don't be surprised if you see something like this. Okay. So this linear transformation of the random variable X includes both the transformations that we performed earlier, which was multiplying by 150 and subtracting 100. In general, linear transformation can be written in the form. This is what I was just telling you. Stats usually uses this form. Y equals A plus BX, where A and B are constants. The net effect of this sequence of transformation is as follows. What happens to the shape? What are we going to do to the center? Is that it? Not or, but and. So it's both. So mean is multiplied by 150. And then subtract 100. So what would that look like? The mean of V. You would subtract that 100 and multiply by 150, the mean of X. Sorry, y'all. Paper is not where we're going to need today. And then what about spread? Standard deviation, we're only going to multiply. So the standard deviation of V would only be the standard deviation of X multiplied by 150. All right. Effects of a linear transformation on a random variable. If Y equals A plus BX is a linear transformation of the random variable X. Then the probability distribution of Y has the same shape of X if B is positive. So B is greater than 0. If you need to write B is positive, you can write that. And then the two things that we just wrote. The mean of Y will be A plus B times the mean of X. Sorry, y'all. And then the third thing is the standard deviation of Y will actually be the absolute value of B times the standard deviation of X. Our standard deviation is a distance, so it will never be negative. So that's why they do the absolute value of B. Okay, so it's not going to be negative. All right, last page. Just a little bit of writing and everything you've already done. Part A on the example is what we did today. Part B is what we did last section. Okay.
So let's put it after what happens when you look at it, you say you don't have to take the stop.
Yep.
What the equation.
Yep. Yep. All right, the bottom two rules in the summary don't just apply to means and standard deviations. This is the last page, y'all, I'm sorry. Linear transformations have similar effects on other, should say, measures of center or location. So we didn't do any of these, but it does affect the median, and I showed you the median, quartiles, and percentiles, and spreads. We just did standard deviation, but we could also do range, and I showed you that one, and then IQR. Whether we're dealing with data or random variables, the effects of linear transformations are the same. Note that these results apply to both discrete and continuous random variables, so it doesn't matter which kind of variable it is. All right, so I wanted to do this example and stop because part B goes back to what we did yesterday, day before, whenever we did it, day before yesterday, Tuesday. So it says one brand of bathtub comes with a dial to set the water temperature. When the baby safe setting is selected and the tub is filled, the temperature X of the water follows a normal distribution with a mean of 34 degrees Celsius and a standard deviation of 2 degrees Celsius. So mean is 34, standard deviation is 2. Well, we don't know what Celsius is, so we want to change that to Fahrenheit. Everybody got it? So remember what I told you that was coming back up. So define the random variable Y to be the water temperature in degrees Fahrenheit. Recall that Fahrenheit is 9/5 C plus 32. When the dial is set on baby safe, find the mean and standard deviation of Y. Okay. So how would we find the mean of Y? The mean is affected by everything. So we're going to do the whole formula, but instead of putting C, we're going to put the mean of X plus 32. It told us the mean of X, or the Celsius mean, was what? So 9/5 times 34 plus 32. I'm going to tell you gives you 93.2 degrees Fahrenheit. But they're not going to die. All right, so that's the mean. How do I find the standard deviation? What is the standard deviation affected by? Only multiplication, so I'm only gonna do the multiplication part. Do not do the addition part. This will be on your test, I'm sure. So we're just gonna do 9/5. What was our standard deviation? 2, which is 3.6 degrees Fahrenheit. So this is give or take 3 degrees, almost 4. That's it. Okay. B. According to the Babies R Us, the temperature of a baby's bathwater should be between 90 and 100 degrees Fahrenheit. Find the probability that the water temperature on a randomly selected day when the baby safe setting is used meets the Babies R Us recommendation and show your work. So what is the probability that we're looking for? We defined it the other day, P parentheses. What are we trying to find? What is it? How do I write that? 90 to 100 what? Degrees Fahrenheit. Remember, that's what we were trying to find right here. So watch the variable that you use. How do I write it? Perfect. I used Y because Y is the Fahrenheit. Okay.
I can write it, but when it comes to saying it,
Okay, as long as you can write it. They don't do a verbal part on the exam, so I don't care. All right, how do I do this? I could do it by hand, but I don't want you to do it by hand. How do you do it in the calculator? Yeah, where's that at? Normal CDF. What comes first? Lower, which is 90, then comes upper, which is, then comes mean, which is, nope. That was the Celsius mean, 93.2. And then the standard deviation of 3.6. Everything has to be Fahrenheit because that's what we're using now. Okay. When you put that in your calculator, you will get 0.7835. And I need you to tell me what that is. Okay, stop right there. There is a 78.35. They say about a 78% chance. I'm happy with the full like decimals. That makes me know that you did it right. You're not rounding wrong or anything crazy. And then what were we trying to find? It already tells you what you're doing, what probability that we were doing. That whole context right there. It tells you in the problem exactly what to write. So don't get so confused on like, oh my God, what do I write? It's right there. That the water, temperature on a randomly selected day when the baby's safe. And I know it sucks to write all this, but that's exactly what they want. Setting is used meets the Babies R Us recommendation. And that's it. We'll keep working with this the Pete's Jeep store, whatever the rest of it. I mean, it's a lot. You'll get tired of it. Yeah. His sister is about to come into play. It gets dramatic, I'm telling you. They have feuding businesses. They really don't. All right, y'all. That's it. You can go do your homework now. I'm gonna stop sharing, stop recording.